Okay, so the problem is 2111, the minimum operations to make the array k increasing. Okay, I already read the problem. So the first thing that I came up with is so look at the last element of the array. For example, the example 1, it is 1, and so if we select 1 as the last element of the increasing array, since k is 1, we have to check the previous the index I minus 1, and I now is 4, so we have to check the value at index 3, which is 2, and so it is incorrect. We have to make an operation. So operation count will be added 1. Okay, I think we will count in a reverse way, so that we will try to find the longest increasing array we will try to find the longest increasing array that is k increasing, and for the return value we will have the length of the total of the whole array, like example 1, it is 5, and minus the longest increasing subsequence. But yeah, I just thought that maybe since finding the longest subsequence, I'm thinking of maybe some of the situation is not covered, because we have to make every element in the array that is k increasing. So it is not just trying to find the longest one, but also every element has to obey the rules. So okay, let's back to the first example. So for the last element 1, which has the index 4, we will look in the previous. Okay, so if but I'm thinking if we find the longest subsequence, increasing subsequence, and so the minimum operation will be n minus the length of the longest subsequence. I think that maybe is correct, because that is the minimum operation that we should done to make the array acceptable. Okay, so yeah, I'm thinking of if every element has a different operation to perform, is it the is it? Will the answer be the minimum? Yeah, I am not sure about this. Okay, let's back to the first example. So if we change the problem to finding the longest increasing subsequence, not subsequence, but the k increasing subsequence, if we try to find it, yeah, maybe we can have some idea. Okay, so for the last element, if we select this element, then the problem will become trying to find the longest subsequence in the rest subarray. That's maybe well, the constraint is 10 with the power of 5. So if we use if we use the tradition LIS, longest increasing subsequence solution, it will time out. So maybe we should change it to the greedy part, the greedy thing, like use the greedy approach with binary search. Okay, so if we try to maintain it's because I want to use if we use the greedy approach, and so that is iterate through the array, and if the element is larger than the last element of tail, then append it after it. If not, try to find the index in the tail and replace it. And we will remain the tail increasing. But now we have the limitation of k, so of k, I am not sure if we use the greedy approach how. I came up with an idea, is that so if we add the first element in tail, like 5 in tail, the next element we should look at will be the index of 5 plus k. So in the first example, it will be 4, which has the index of 1, and yeah, I'm thinking of maintaining um, like n number of tails array so that we can know the longest length of the longest length of the sub of each index, starting from each index. And then we will have n minus k number of tails array, and since we can know since we can know each longest increasing subarrays length of each, starting from each index, we can calculate the minimum number of operations that required. Yeah, I'm thinking of if starting from this index, it needs like 3 operations, and the other index needs like 2 operations. So, will it be like the answer will be 2 or 3? Maybe let's make some edge case. I will have like so maybe k is 2, and have like decreasing array, and okay, it is. So if we have like this, so it will be 1, right? But the longest increasing subarray will be 2. I think, okay, so another thing that I'm thinking of is the length of the k increasing subsequence is fixed. Okay. Okay, there's some okay, is okay, so the length of the k increasing array is fixed. Like yeah, so the length of the k increasing array is fixed to and divided by k. Yeah. So we will see yeah, I think the time complexity should be a big O(n), else we will not pass the submission test. So we will try the greedy method and so loop through the array and also maintain k number of thinking of if we have like no this so the fixed array is the length of the fixed array, the length of the k increasing array will be 5 divided by 2, which is 2, and oh, there's 3, and Okay, this is not working. We don't know if if I loop through array and then maintain every tail of the starting from every index, but I think I might have the idea of every subsequent length. So for example, for the case that I proposed, like the first subsequence will be 5, 3, 1, and we will try to find its longest subsequence, and then it will be 1. The length will be 1, but when I loop through the array, I know its maximum length will be 3, so it needs to replace 2 numbers, so the operation will be 2, the operation count will be 2, and then the other array starting from index 1, it has a length of 2, and its maximum length is 2 as well, so it doesn't have to do any operations, so the answer will be 2. I think it kind of makes sense. Right? So I think, but the time complexity is O and with the power of 2. No, because we don't. Oh, maybe we don't have to. Yeah, we can loop through every element and use the modular. Is that pronounced like module? This calculation and check which subsequence is it in, and yeah, so we can only run through once for the whole array. Yeah, I think that's a good idea. Okay, so that's okay, so I think we will first maintain a grid that has Okay, so for the index to know where to stay, which okay, so this index is 0, this one is 2, this is 4, okay, so that is if your index module by k has the same amount, then you will be in the same group. And yeah, so and how many groups will there be? Will they be oh, so they will have two, no, is it 2 groups? No, it is 3 groups. 2 groups. So not a grid maybe, but yeah, since we are not sure how long, okay, so we will have 2 grid, 2 so for the data structure that we want to use to store to store the calculation of the longest increasing subsequence, it is the number of the group will be k. Yeah. We use the greedy approach. Oops. Binary search. We will maintain k number of tail, and so it will be like I think we will use a dictionary and or because I'm not sure how to like use the fixed number of, yeah, maybe let's use a default dictionary. So it will be like and we will call it tails. And okay, so we will for loop, we will iterate array, and if its index module by k we use its index module by k to see which tail should it belongs to. And then we will start maintain its longest subsequence. Longest non-decreasing that is if that is we will find use bisect right to find the last find the last element in tail. To find the last element in tail, and replace the next index to the current value. If where's the current value? Yeah. And the one thing that we have to do is we have to check, we have to know the length of each like how many values we have been calculated. I first know it, yeah, I'm thinking of, or maybe we can loop through again, loop through the whole array and try to form a grid, and then we will do but then we cannot, we will not, oh yeah, we will do 2 times. So the first time we will maintain the tails, and we will know each longest non-decreasing subsequence starting from each index, and then we will loop through the array again to see the maximum, to see the like the length of each subsequence that should be, and we will do a minus and sum up the minimum operations that we have to do. Yeah, I think that works. And that is like an operation. Yeah, the time complexity is n. So then we will, after the calculation of tails, we will loop through the array to calculate the minimum operation. Okay, so for value in array, we will do a bisect right binary search. All we need is index, because to do the calculation of which tail is it in. So it will be like this. And the target is value. So if index is smaller than the length of tail, then we will replace it. So it will be we will have this. And then else, if it's larger than tail, then we will append it after it. So we will have the length. Okay, so now we already have the longest non-decrease, the length of each subsequence, and we'll do a count here, and then we can know. No. Yeah, if it cannot append, then it should be calculated. So let's maintain the count. And the count will be the answer. Oh. Oh. Okay. Okay, so let's see. Oh, we have like let's see the solution. Oh yeah, you can like this guide. It sums up every longest sub-array of starting from each index, a subsequence, starting from each index and use the n to minus. Yeah, that can also work. So, and that doesn't need yeah, it also needs like n yeah, it kind of need yeah, the space size is the same, because yeah, for every index, for every starting index, it also maintain 1G. So no, oh, but we can only maintain n space at a time. Don't need, since we can yeah, we can like do 2 to 4 loops. Yeah, okay, I think that's all for this. Well, we can do it like this. So we'll have a total like sum of length, then we can do it, we'll have value, no, we'll have I in range we'll first have the n as the length of the array, and we'll have we will start from 0 and then end it at the end, and but the step will be k. No, it will be 0. Oh, it will be x, and it is like the you will do it like, I think you will do it like for I in range 0 to k, like I think k, and then yeah, and then we'll have tail here, So for each starting index, we'll have a tail, and yeah, we will do the same thing. The right boundary binary search. Input a tail, and then the value is array I, and yeah, if index is smaller than tail and the length of tail, then we will replace the index at tail, the value at index to the value. Our value is this. Let's use it like this. So it will be value, and else if it's larger or equal to the length of tail, then we will append it after it. So do an append. Then after the for loop, we will sum up its length. Then at the end, we will return the end minus subsequent. Yeah, I think this will work as well. Yeah, it's faster. Okay. And that's the end of this problem.